Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you. All right. So today we go for the tutorial 5. All right. Actually, tutorial 5 divided by two parts. Okay, part 1 will be on the DC bridge. Okay, and then the part 2 will be cover on the AC bridge. Okay. So if you refer to the tutorial 5, all right, already given to the group. So on the tutorial 5, question number 1, okay, here until question number 6, okay, question number 6, all right, until question number 6 will be covered for the DC bridge. Then the rest will be covered for the AC lah. That's mean from question 7 to 11. 11 will be covered for the AC bridge. Okay, so today we try to focus on the DC bridge. All right, so from question number 1 to question number 6. Okay, question number 1 to question number 6 lah. Right, so if you refer this one, okay, we go for one by one for tutorial 5 part 1 for the DC bridge. Okay, so the question number 1, what does bridge know or balance means? Okay, so this one is the theoretical. You can get from the notes, okay, from the Googles. Okay, what is the bridge? Okay, bridge null or balance. Okay, means. Okay, so from the notes you can see the bridge is said that at balance when there is no potentials difference between the meter or no detector lah. So no current flow through the meter. That is we call the balance lah, the bridge balance. Okay, so that means R1 over R2 equals to R3 over R4. Okay, so that is the balance. There is no potential difference between the meter. Right, so this is question number 1. Okay, now what is the theoretical? So let's go for the question number 2. So number 2, maybe I copy this one. All right, I copy. Okay, let's share. All right. Okay, so this is a question number 2. Question number 2. Okay, question number 2. Right. So figure 1. Okay, this is figure 1. Show a diagram of the Wheatstone bridge with the constant R1 equal to hundreds. Okay, right here it's a hundreds ohm. Okay, R2 is 1000. Okay, or 1 kilo ohms. 1000 kilo ohms. And RT is a 200. Okay, RT is a 200 ohm. Okay, 200 ohm. Right. So first determine the value for the unknowns arm. There is R4. There is the variable resistor. Okay, if the bridge is in the balance. Okay, there is question number A. 1 to A. And then for B, if the value of R4 is changed to 2002. Okay, the R4 this one will be changed to 2002. Determine the current. Okay, this one the current through this one the current through the galvanometer Ig if the battery this one is a 5 volt that means the supply will be 5 volts. Okay, 5 volt, and the internal resistance, okay, internal resistance is negligible. That means inside this one inside the is a Rg. Okay, so on the galvanometer is neglected. So hence find the deflection of the meter if the sensitivity is 10 millimeter per microampere. Alright. So we solve this one. First, so as I mentioned to you before this, so at balance, okay, at balance, which is balance. Okay, so this is the formula for the balance R1 over R2 equals to R3 over R4. Okay, so cross multiplication. So R1 divided by R4 equals to R2 multiplied by R3. Right, so now you want to find the R4 because the R1, R2, and R3 are already given. So we formula R2 multiplied by I3 divided by R1. Okay, so just substitute the value for R1, R2, R3, okay, to this equation to get the R4 lah. So R2 equals to 1K, so 1K, 1 kilo ohms multiplied by R3 is 200. Okay, and then divide by, okay, 100. Okay, so R4 equals to, equal to 2000, 2000 ohms or 2 kilo. Okay, 2 kilo ohms. Okay, 2000 or 2 kilo ohms. That is for R4. This one is the R4 lah. Okay, so we go for the next, the B. To B is the, if this one, okay, R4 change to 2002. Okay, R4. R4 equal to 2002, and then we want to find the deflection. Okay, deflection of the meter if the sensitivity is 10 millimeter per microampere. Okay, so from this equation, so we can use, first we have to find the VTH, right? So VTH, okay, so as the on the balance equation, so as you know, so this point, okay, this means the VCA, okay, this one, voltage here, we call, maybe we can put as this one is the A, C, this one C, this one D, declare as a D, this one declare as the B lah. Alright, so this one A, AC, okay, AC, this means AC here equals to AD lah here, voltage AD lah. Alright, so or we can use the formula. So this is already given the formula, so you can check on the note how the formula come, right? So R1 over R1 plus R3 minus R2, right? R2 plus R4. Okay, so first we have to find the VTH. Just substitute the value. All right, E is 5 volts. Okay, and then R1 is 100. Okay, R1 100 plus R3 is 200. Okay, this R2 is 1K. Okay, R2 is 1K plus R4 is 2002. Okay, so equals to, you can use your calculator to get the value for VTH. VTH is equals to 1.1 millivolts. Okay, actually from this one you can simplify to this one, right? So something like this. Okay, we want to find here. Okay, we want to find, so this one we call the VTH, and this one, this is RTH, right? So we want to find the RG or RTH here. Okay, RTH here. So because of this one, the internal resistance is negligible. That means internal, the RG is equal to 0 lah. Okay, equal to 0. So no RG here. Okay, no RG here. Okay. All right. So then we got the VTH, so you want to find the RTH. Okay, RTH. Okay, also you can use the formula lah. Okay, on the notes, actually this is a formula to calculate the RTH. Okay, so R1 multiplied by I3. Okay, R1 plus R3 plus R2 R4 R2 plus R4. Actually, after we simplified this one, so the circuit similar like this. Okay, this one, this one. Okay, this one R1, R3, R2, R4. Sorry, so R1 parallel with R3, R2 parallel with R4 to get the RTH, RTH here. Okay, from point, this one we call point here to the point here. So this is a formula, how it's come from this one, this circuit. So get this one, the equation, and then just substitute the value, okay, the value for R1, R3, R2, and R4. 200 multiplied by 200 divided by 300, okay, plus 1000 multiplied by 2002, okay, divided by 3002, okay, 3002. So using your calculator, okay, the RTH equals to 733.56 ohms. Okay, so this one RTH equals to 3733.56 ohm, and this RTH equals to 1.1 millivolts. And then from formula V equals to IR, so we can calculate the RTH, okay, or RG, voltage divided by R. Okay, so substitute the value for 1.1, okay, milli, and divide by 733.5 ohms. Okay, so the current will be 1.5 micro ampere. Okay, that is the current total, current IKH or current total here. So on this circuit. Okay, so the answer for the current will be, okay, the will be 1.5 micro, 1.5 micro. And then the formula for deflection, okay, equals to S over current. S multiplied by current total lah. Okay, so the sensitivity is a 10. Okay, 10 multiplied by 1.5 micro. This is M millimeter, and this one is a micro. So this the answer will be, because this one mm per micro, so will be cancel out, so will be 5 millimeter. Okay, this is the deflection. Okay, the deflection of the meter. Okay, so this is question number 2. Okay, so next we go for the question number 3. Right, so this is question number 3. Given the Wheatstone bridge as shown in the figure 2, R1 is equal to 50. R1 equal to 50K, alright, and then R2 is 10K, R3 is 500, okay, 500 ohm. Okay, VDC equals to 10 volts, and the internal resistance of galvanometer is the RG equals to 100 lah. Okay, this one inside this one RG is 100 ohms. Okay, first obtain the value of Rx when the bridge is valent. So this is similar like question 2, okay, to question 2A. So just straightforward using the formula. Okay, the Rx or R4 lah, R4. So R2 multiplied by R3. Alright, so divide by R1. So this one you can refer to the previous question number 2A. So how this equation obtained. So just substitute the value. Okay, so R2 is the 10k, R3 multiplied by R3 is a 500, sorry, 500 ohm, divided by R1 is the 50k, 50k. So is the Rx is 1000 ohms. Okay, 1000, sorry, 100. It's the 100 ohm. Okay, you can use your calculator to calculate the value of Rx. So the Rx is equal to 100. Sorry, not 1000. It's the 100 ohms. Okay, 100 ohm for Rx. And then we go for the equation B. If the value of Rx change to 200, so this R4. Okay, next will be changed to Rx change to 200. Okay, calculate the current Ig. All right, so that will be flow through the galvanometer and determine the deflection of galvanometer if its sensitivity of 2 cm per ampere. All right, so this is similar like question 2b, but this one we have the Rg lah. Okay, so the Rg equals to this one already given, this one already given. Okay, so after we have simplified this one, so this one we call the VTH and we have the RTH. Okay, and then we have the Rg here. Okay, so this one Rg here. Then we have to calculate the ITH or Ig lah. Okay, we can call the Ig or ITH. Okay, this one state as the Ig, the current. They calculate the current on the galvanometer lah. All right. So the first step we have to calculate the similar like the previous tutorial, previous question number 2b. Okay, VTH equals to E. Okay, just straightforward using the formula plus R3, okay, minus R2, 2 plus R4, Rx lah, sorry, Rx. Okay, and then substitute the value 10. Okay, 50k divided by okay, R1 50k plus R3 is 500. Okay, R2 10k, 10k plus Rx is 200. Okay, so using your calculator, okay, to solve this one to get the so using calculator get the 97 millivolts. Okay, for VTH. Alright, so next you have to calculate the RTH. Okay, similar like question 2b, just straightforward using the formula for RTH. Okay, R1, R3 multiplied R3 divided by R1 plus R3, okay, plus R2 multiplied by R4 equals to R2 plus R4. Okay, so substitute the value 50k multiplied by 500 divided by 500.5k, okay, plus 10k multiplied by R200, okay, and then okay, plus is a 4 kilo. Right, so the RTH equals to okay, you can use your calculator lah to get the RTH 1.13 ohms. Okay, so this one VTH 97 millivolts. This one RTH is 9691.13 ohms and Rg equals to 100. Okay, so we can calculate the Rg or RTH. So this is formula for RTH. Sometimes also Rg lah. Right, VTH divided by RTH plus Rg. Okay, so substitute the value for this one 7 milli. Alright, RTH plus 100. Okay, so the Rg or RTH equals to 122.6. Okay, you can use your calculator. Use calculator to get the value for current. All right, so 122.61 microampere. Okay, and then next you have to calculate the deflection. The formula is similar. Okay, S given, okay, S is 2 cm per ampere, right, multiplied by 1.61 microampere, cancel out the ampere, so the division is at 0.025 milliamp. Okay, this one maybe you can convert to milliamp, then you can multiply with current here, current IT here. So that is question number 3. Okay, that is question number 3. Okay, so we go for the next. We go for the question number 4. Okay, question number 4 will be is application, actually an application of the Wheatstone bridge lah. So you can read this one. So the Wheatstone, okay, the Wheatstone bridge is connected for the valley loops test as shown in the figure 3. So when switch is the set to the position A, this one set to the position A. Okay, this means yeah, will be changed to A here. Okay, the bridge is balanced. R1 equals to 1K, R2 equals to 100, R3 equals to 53. Okay, 53 ohms. Okay, when the switch to position B, okay, change to B, so the bridge is balanced. The RT will be changed to, okay, so for position A, I put here, so RT equals to 53 ohms, okay, and then we change to B, so R3 equals to 92.9 ohms. So if the resistance of the shorted cable is 0.015 per meter, okay, how many meter in the distance from the bridge to the ground, okay, to the ground fault. Okay, so there is a question. So how many meters? So first, okay, so at the position A, as you know, at the position A, so this is position A. At the position A, I put it here as A. So this is formula R1 RA plus RB. Okay, this one you can refer to the notes how I get this equation. So R3, then to RA plus RB equals to R2, R3 divided by R1. Okay, so just substitute the value here, 100. So R2 is 100 multiplied by 50, R3 is 50, and divided by 1K. Okay, so the answer will be 5. Micro ohm, 5.3. 5.3 ohm. Okay, so this one you can use calculator. So this means the value for RA plus RB is 5.3 ohms. Okay, then next we go for the position B. Okay, the position B same. Okay, so R1 RA plus RB plus Rx. Okay, because we have the Rx here. R2 R3 plus Rx. Okay, and then we just we can multiply. Okay, this one multiply, and then after multiply we can rearrange the equation to get the for example we can multiply lah. Okay, R1 RA plus R1 RB plus R1 Rx equals to R2 R3 R2 Rx lah. Okay, and then we can rearrange. Okay, so we get like this. Maybe I just simplify the equation. Okay, from this equation you can get the Rx lah. So the Rx equals to RA multiplied by sorry, R1 multiplied by RA plus RB, okay, minus R2, R3 divided by R1 plus R2. Okay, so from this equation, so just after this you can try how to get the Rx. So just simplify this one. Okay, so 1 kilo, R1 is 1 kilo, okay, 4.3, get this one, RA and RB is 4.3, okay, minus 100, okay, multiplied by R2 is, okay, so 1.1 kilo, okay, so the Rx equals to 9.09 milliohms. Okay, that is for on the position B lah to get the Rx. Rx is a 9.09 milliohms. Okay, so as we know, okay, when we convert 0.009 ohms equals to okay, 1 meter. Actually, 1 meter equals to 0.015 ohms. Okay, and then from this one, okay, we can get how many meter lah. So using this formula, alright, so 0.0009, okay, this one is 1 multiplied by 1 over 0.015. Okay, so the answer will be 0.6067. Okay, on meter. So convert into cm, so will be 60.67 cm. Okay, that is the length lah. Okay, the length from the bridge to the ground floor. Alright, so that is question number 4. So the answer will be 60.67 cm. Okay, from distance from the bridge to the ground. Okay. Alright, so we go for the question number 5. Okay, question number 5. Right, question number 5. Also application, also application of the Eastern Bridge. Okay, figure 4 show an application of the bridge to control the motor. Okay, so we have the motor here. When there is no light beam direct to the potentiometer, so this one is a 10K. So the resistance of the photocell R will increase to 10K to 40K, right? From 10K to 40K. If it is interrupted by the light beam, so the motor will be on when the current through amplifier I in, okay, amplifier I in here is higher than 50 microampere. Okay, so what is the current I in, and what happened to the motor when, okay, first is there is no light beam direct to the potentiometer, and second is the potentiometer is interrupted. Okay, first we have two conditions. So first question, no light beam direct to the photocells, and second condition is the photocell is interrupted. Okay, so we go for A, condition A, R equal to 10 kilo ohm. The R will be 10 kilo ohm. Okay, so if the bridge is imbalance, so I in equals to 0 ampere lah. So that means motor will be off. So this is for so what happened to the motor? Motor will be off, not turning. So motor will be off. Okay, when bridge is balance, there is no light beam. Okay, for condition B. Okay, B, if the photocell is interrupted. Interrupted. Okay, so interrupted, that means the bridge is not balanced, unbalanced, we call it unbalanced. Okay, so there's first we have to calculate the VTH. VTH using the formula for calculate the VTH. Okay, R1 plus R1 plus R3 plus minus, sorry, minus R2 plus R4. Okay, so equals to 10K divided by 50K minus 10K divided by 20K. So using your calculator to get the answer will be 0.9 volt. 0.9 volt lah. Okay, so this is absolute. So you can see this one. So this is lower than this one, minus. So this one will be get the negative. So we have to absolute. So the VTH supposed in the positive. So absolute. So that's why the answer will be 0.9 volts. Okay, 0.9 volt lah. For this is for VTH. Then next we have to calculate the RTH. Okay, the RTH, okay, using the formula. Okay, using the formula 10K multiplied by 40K divided by 50K plus 10K plus 10K divided by 20K. So the answer will be, okay, using your calculator to get the answer, RTH equals to 13 kilo ohms. Okay, and then we can calculate the current I in using the formula lah, VTH divided by RTH plus RG. Okay, or R in. Okay, and then substitute the value 13K plus 1K. So the value is 64.3 micro ampere. That is for current, for current. So the condition is if I in equal to 64.3 microampere and greater than 50 microampere. Okay, so this is the one, the condition, the condition here. So the answer will be motor will be on. Okay, motor will be on. This means motor will be rotate. Okay, the motor will be rotate. So this is for question number 5. Okay, the condition lah. So the first condition motor off and second condition motor on because of the, for example, for second condition is the photocell is interrupt. So the I in greater than 50 microampere. So the motor will be on. Okay, so next we go for the last for the chapter DC bridge, question number 5. Sorry, question number 6. Sorry, question number 6. Okay, so question number 6. Calculate the current I in the circuit as of the figure 5. Okay, so when the temperature is 50 degrees Celsius, if the resistance is 500 at 25 degrees Celsius and its resistance increase to 0.7 per degrees. Okay, then we have to calculate the I in. So we have the condition. The first condition, okay, when temperature is 50 microcelsius, the resistance is 500 ohms, and then second condition is 25, okay, 25 degrees Celsius. The resistance increase to 0.7. So we have R1, okay, R1, okay, sorry, R equals to 500 at 25. So increase, we increase 0.7 ohm per Celsius. Okay, so at the 50 degrees per Celsius. So that's formula, right? 25 degrees Celsius multiplied by 0.7. 0.7 increases, okay? Then plus 500 lah. So that is to calculate the the resistor. So resistor will be 570.5 ohms. Okay, the resistor will be increased because of this 0.7. Okay, 0.7 increase 0.7 lah. Okay, ohm per Celsius. And then we can calculate the VTH. Okay, VTH using the formula. Just say using the formula 570.5. Okay, divided by 1.5 minus 500 by 1000. Okay, so E is a 1.5. E is 1.5 here. Okay, so 1.5 multiplied by 8.6 milli. So the VTH equal to 12.9 millivolts. Then next we have to calculate the RTH. RTH, just use the formula. 5 multiplied by 500 divided by 1.75, okay, plus 500 by 500, okay, by 1000. Okay, so using your calculator, so the answer will be TH equals to 504.3 ohms. Okay, and then you can calculate the current ITH or IN. Right, so the formula VTH, RTH plus RJ. Okay, so our RIN. Okay, some of the books refer to the RJ, some of the book refer to IN, but it will be same lah. Okay, we can simplify this one. So our circuit will be like this lah. This is RTH, this we call the VTH, and then this is RTH or RG, and then this is RG. So I just substitute the value. Okay, 1.3 ohm plus RG equals to okay. Okay, so RTH equals to 2.37 micro amp. So that is for current. That is for current. Okay, so that's all for chapter 5, part 1. All right, for the DC, we will cover for the DC bridge. All right, so next I will go for the next video. I will go for the bridge tutorial 5, part 2. This will be covered for the AC bridge. Okay, thank you very much. So next video I will be covered for the AC bridge. Okay. Okay, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.